Claims and evidence are really the basis for science. In science, a researcher will make a claim. They will say something about how they think something is in the world and why they think it is that way. Um, a claim kind of goes back to the whole hypothesis idea, but in this one we're making a statement that something is true. And then the evidence portion is how do we prove that? So what data do we collect? What did we observe in order to prove that our claim is true? And then the last step of that is reasoning. And that's where we explain the evidence. So instead of just having the claim and then listing a data table after it, we have to explain why that evidence actually supports our claim and how that makes it to be true. So as we work through this lesson, you have a packet that looks like this that's on the screen. You need to make sure that you have that with you. This here, you're going to need this, and you're going to need it for the whole semester because we're going to keep coming back to claims and evidence, and you're going to want to look back at this until you kind of get the hang of it. So you want to have this out while we're going through the different sections. We're going to first start with Center 1, and in Center 1 we're going to talk about what is a claim. So a claim is an overarching statement. It's a big idea. It's a concept. It's not about something narrow. It's about something broad. And in our cases, it's either going to be something that's either based on observations from a lab that you've conducted, or it could be from a video that you've watched, or it could be from an article that you've read. So it's not just about being on a lab, but it can be from observations that other people have made as well. Just kind of depends on what the assignment is. So it needs to be related to whatever, if it's part of a lab, if we're using this as our analysis and conclusions portion of our lab, then it should be related back to your beginning question or to what your hypothesis was. In a video, when we're watching a video, or if you're reading an article, it should all go back to what is the main idea of what's going on here, because really in a lab, that's our main idea, is our beginning question. And it's specific. It tells what the impact is, or it tells what the difference is. You don't just say that something makes a difference. You say what that difference is and how does that happen. And we'll look at some examples here in just a minute. What claims aren't are random unconnected thoughts. So it's not that we did a lab that was on weather and then you write a claim that's based on, I don't know, the temperature of the ground, or, something that's completely unrelated to what it was that we were doing. You want to make sure that it actually goes back to that main idea of the lab, goes back to that beginning question. It's not data. So you saying something like plant 5 grew 7 centimeters is not a claim. That's evidence. So we're going to talk about the difference between claims and evidence and how evidence supports the claim. But we need to make sure that our claim is actually that overarching statement. It's not a hypothesis, and it's not general. So here are some good examples of claims. Convection causes movement in the mantle. That's one that we looked at last semester. And so we collected data, right? We collected some qualitative data because we couldn't really do quantitative with that lab. But you looked at the movement of the dye through the water, and that was data. We looked at how the sticks moved across the top. That was data. Larger meteoroids create larger impact craters. It's a bigger idea. How does this impact that? And then we can collect data. We can look at the data from how big was the meteoroid, how big is the impact crater. We can collect data to prove that's true. Faster moving meteoroids create larger impact craters. Also something that we can measure. Speed at impact has a greater impact on crater size than the size of the meteoroid. Also something that we can measure, right? And we can compare, and we can come to that conclusion. Oceans have a stabilizing impact on coastal climates. We can look at the climate, the changes in climate at the same latitude, at the same elevation, and we can look at close to water and far away from water, and we can see what influence that has. Higher pressure in the magma chamber results in more explosive volcanic eruptions. Once again, you see there's no numbers in these examples. There shouldn't be any numbers. It should all be back to a larger concept. So, on your handout, you have some examples and non-examples of claims. So you're going to put a star next to the statements that are claims, and then you're going to leave the other ones blank. And I'm going to give you a couple minutes to do that, and then we'll talk about it in your groups. All right, so now you should be looking at it with your groups or at your tables, the people sitting next to you, and kind of look at it and say which ones did you think were claims and which ones did you think were not claims. So in this first column over here on the side, earthquakes occur every 24 years in Southern California. Well, our first hint in this one is that it has a number in it. If it has a number, it's not a claim. If that had been a different type of statement, earthquakes occur frequently in Southern California because of fault lines, that would have been a claim. But because it says a specific number, this is data. This is not a claim. Our second one, deserts occur in rain shadows of mountains. This is a claim. It's a general statement that's about a larger concept. We'll talk a little bit later on about a rain shadow if you don't know what that is. The relative humidity is 85%. Not a claim. This is evidence. Once again, it has a number in it, right? And that makes it evidence just off the bat. But this is also, it's not about a concept. It's about the conditions at a certain time. Pressure between two continental plates creates mountains. Now, this one can be a little confusing because it does have a number in it. However, the number is not the same kind of thing. This one's just saying because there's two plates that are pushing together, we get mountains, and so that makes it a claim. Up here, this one's different just because it's talking about 24, a number of years. So this one is a claim. How does increased heat and pressure affect an igneous rock? Well, first of all, it's a question, which makes it not a claim, right? A claim is a statement of how something is true. So we could say increased heat and pressure, and then say how does it affect the igneous rock, and that would make it into a claim. But as it's written right here, not a claim. Warm air can hold more moisture than cold air. That is a claim. Increased stress on tectonic plates results in earthquakes. This is a claim. If air pressure increases, then the amount of moisture in the air can increase. Also a claim. That's also a claim. Earth has layers. This is a claim. Earth's core is 15% of Earth's volume. This is not a claim because it's a specific number. This is the end of Station 1, or Center number 1. So at this point, you're going to go ahead and go to Station 2. You'll go to the next part in campus.